You know when you've got like a million tabs open in your web browser and your computer starts to slow down?
I know that feeling.
That's kind of what's happening with AI right now. These huge models, they're really powerful, but they guzzle energy and they cost a fortune to run.
It's a real problem.
So what if there was a way to make AI more focused? Like only using the tabs it needs, when it needs them?
Now that would be a game changer.
Well, that's what today's deep dive is all about. We're digging into this fascinating new paper called From Sparse to Soft Mixtures of Experts.
Catchy title.
Right. But it's about making AI more efficient, which has huge implications for, well, pretty much everything.
It's about time, to be honest. We've been so focused on making AI bigger and bigger, but there's a limit to how far that can go.
Yeah, bigger isn't always better, is it?
Exactly. There's this concept called scaling laws. Basically, it says to make AI smarter, you need more data. But more data makes it more complex and harder for people to actually use.
So this paper is trying to break those barriers to make powerful AI more accessible.
That's the goal.
So how do we actually make AI more streamlined?
Well, this paper focuses on something called mixture of experts, or MOE. It's not a new idea, but they're pushing the boundaries.
MOE, okay, so for those of us who aren't AI experts.
Sure, imagine it like this. Think of a hospital. You wouldn't see a cardiologist for a broken bone, right?
Makes sense.
MOE is similar. It lets AI activate only the specific experts that are relevant to a particular task. Saves energy and resources.
So instead of the entire AI system running at full power all the time, it becomes more strategic.
Exactly. Only the parts that are needed for the job get activated.
Okay, so that makes sense. And I know there are already a couple of ways to do this MOE thing. The paper mentions token's choice and expert's choice.
Hmm.
But I'll be honest, those sound kind of like something out of Star Wars.
Well, they are pretty technical terms.
Right. But the really exciting stuff, the real breakthrough here, is what they're calling soft MOE.
Now, that's where this paper gets really interesting. See, the old ways of doing MOE were kind of rigid, like sorting mail into boxes. This data goes here, that data goes there.
Okay, I'm visualizing that, yeah.
But soft MOE is more like blending ingredients. It figures out how to distribute information as weighted combinations, so every expert gets a tailored mix, but nothing gets wasted.
Elegant. I like it. So instead of hard categories, it's more nuanced.
Exactly. And that nuance is where the magic happens.
Okay, that sounds amazing in theory, but does it actually work? You know, sometimes in AI research, you get these cool ideas that don't quite translate to the real world.
Right, you need to see the evidence.
Exactly.
Well, in this case, the evidence is pretty compelling, and they lay it out really clearly in the paper with some nice visuals, too, if you're into that sort of thing.
Always.
Figures 3, 4, and 5, they show how soft MOE just consistently outperforms the other methods, like hands down.
So we're talking hard proof here, not just trust us, it's better.
Oh, yeah, no, this is not just a hunch. We're talking significant improvements.
Yeah.
Often they were able to achieve the same accuracy as the traditional models, but with way less computing power. Sometimes even like a large fraction of the computing power.
Which, for our listeners who maybe aren't knee-deep in the AI world every day, that translates to faster processing, lower cost, more people can actually use it.
Exactly. And that's what makes this research so important, because it's not just an incremental step. This could really democratize access to powerful AI.
Yeah, that's huge. So I'm curious, when they were building these soft MOE models, did they find like a sweet spot for how many experts worked best? I mean, the paper mentions these slots too, and I'm picturing like assigning different tasks to departments in a company.
I like that analogy. And you know what it turns out? With soft MOE, more experts is often better. It's like adding specialists to a team. It makes the collaboration smoother, not more chaotic, which you might expect.
That's so counterintuitive. You would think, like too many cooks in the kitchen.
Right, exactly. But that's the beauty of how soft MOE blends the information. Now, there is a small caveat with these slots that you mentioned. Because of how soft MOE combines the data, there's a chance that the slots can become too aligned. And that could potentially lead to some memory issues.
Oh, okay.
But it's not a deal breaker. It's just, another puzzle piece for future research to kind of optimize.
So a challenge, not a roadblock.
Exactly.
Makes sense. But here's what I'm really excited about. This isn't just about computers seeing things better, is it? I mean, the applications of this are kind of limitless.
Oh, absolutely. And the paper mainly focuses on image recognition. But these ideas, they could be applied so much more broadly. I mean, imagine this smoother, more efficient AI being used in medicine or in climate modeling, even in creative fields.
Okay, stop. Stop, I'm getting chills. We could be talking AI that helps doctors diagnose diseases earlier or
Mhm.
predicts natural disasters with more accuracy, heck, even composes music.
Exactly. And because SoftMOE makes these powerful models more accessible, suddenly researchers and developers who don't have, Google level resources can start tackling these problems. It's hugely exciting.
The potential for impact is just massive. It
Yeah.
really gets the imagination going, doesn't it? All the problems we could solve, all the fields we could revolutionize. And speaking of revolutionizing fields, there's one application of the paper that really caught my eye. What was it called again? Contrastive learning, right?
Yes, contrastive learning is fascinating stuff. Essentially, it's about teaching AI to see the connections between images and text.
Okay, so like showing a picture of a cat and the word cat at the same time so the AI learns the association.
Exactly. But on a much larger scale, of course, it's like building a visual vocabulary for AI.
And this paper, they showed that SoftMo is good at that too.
They did.
Right.
They ran specific experiments with the contrastive learning, and yeah, once again, soft MOE came out on top. And here's the really cool part. They didn't just use Google's own massive data sets for this.
Which are, let's face it, pretty vast.
To put it mildly, so to prove it wasn't just a fluke, they actually replicated the experiment using a public data set called LAION 400M.
So these results, they're reproducible even without, Google scale resources.
Exactly, and that's crucial for making this technology more widely accessible.
Absolutely. So, okay, let's talk applications. What could we actually do with this?
The possibilities are pretty mind-blowing when you think about it. Imagine search engines that can understand images just as well as they understand text right now.
Oh, that'd be amazing. No more scrolling through pages of vaguely related images.
Gone. Or how about personalized education tools that actually adapt to how each student learns best?
Okay, now that's something I could have used in school.
And this is just scratching the surface. I mean, imagine AI that can analyze scientific data in entirely new ways, making discoveries that would have taken humans years, maybe even decades to uncover.
This paper really does feel like a glimpse into the future, doesn't it? It's not just about making AI a little bit better. It's about changing what AI can do and who gets to benefit from it.
Couldn't have said it better myself. And look, soft MOE is still early days, right? But the potential here is huge. Imagine a world where powerful AI isn't just the domain of big tech companies, but a tool that anyone, anywhere can use to solve problems.
So that's a future I want to be a part of. This has been an incredible deep dive. Thanks so much for walking us through it all.
My pleasure. Always a fascinating conversation.
And to our listeners, thanks for joining us on this journey into the world of AI efficiency and the incredible potential of soft MOE. It's a rapidly evolving field, so keep those questions coming, stay curious, and who knows what amazing breakthroughs we'll uncover together next time. Until then, take care.